Oh, these are sets. These are the symbol for sets. We use braces. When you see these braces, the topic is sets. A set is a group of objects, not necessarily in order. If you notice in set A, it doesn't matter who's first and who's second and who's third. The issue with sets is it in the set or is it not in the set? The issue is membership, not order. Right here we have a rectangle is an element of set A. The rectangle is a member of set A. The star is not an element of set A. That's why we strike it. We could identify sets two different ways. You can use the roster method, in which case you would list the members of the elements. You can actually see who the members are. In this set builder method, you don't identify the members, you describe them. And this is the way this reads. The members of this set are those X's such that those X's are members of the natural numbers. So you're just describing the members, but you are not listing them. Here's a practice problem. Write the set by listing its elements. So right here, they give us a set builder notation. So they're describing who the members of this group are. What we need to do is get 2k plus 1 and start replacing the k with a 3 and then the 4 and then the 5. And so this will produce the members. So the members of this set are 2k plus 1 such that the k is going to be a 3, a 4, and a 5. So you replace, substitute the 3, the 4, and the 5. They take turns one at a time. 3, 4, 5 for the k is. Simplify. It generates these numbers, 7, 9, and 11. So if you want to see who the members are, they are 7, 9, and 11. Here they're being listed. So right here in this problem, we're describing the set. This is the roster method where you actually have the list of members. And you could describe this list more than one way. One way would be to describe it as those X's such that the X is an element of the even numbers. And you could be a little bit more precise by saying those even numbers that go from 2 to 10. Or you could describe the same list of numbers, the same set, you could describe it this other way. The members of this set are those X's such that the X is produced by multiplying 2 times n, where n is coming from the natural numbers. Remember, the natural numbers are the counting numbers. And then you would put another specification that you're only going to go from 2 to 10. You can make this description a little bit more clear. This idea of one-to-one correspondence has to do with pairing members of one set with members of another set. Notice that the arrows are pointing in both directions. All members are involved for there to be a one-to-one correspondence. All the members have to be involved from each set. And all members are paired up with a unique other member of the other set. So each pair is made up of a unique X and Y. And they don't switch partners. The fundamental counting principle, this one answers many questions. Here's one of them. In how many ways can we choose from certain categories? Suppose I had 5 pairs of shoes, 7 shirts, and 6 pants. In how many ways can I get an outfit using each of these categories? Well, the fundamental counting principle involves steps. First, you go to the first category and you say, well, I have 5 items available to choose from. I go to the second step and I have 7 items to choose from. And I go to the third step, and from this category, I have 6 options. You multiply them, and this gives you the number of ways you could choose a pair of shoes, a shirt, and some pants. 210 ways to do that. Here's some terminology. Equivalent sets are sets that have the same number of elements. Notice they don't have to have the same members, just the same number of elements. The symbol for equivalent is this sleeping S looking thing. Cardinal number is a number that has counted how many members a set has. And this is the way it looks when you write it. The number of members of set A. That number is called a cardinal number. The empty set can be written three different ways. You could say the empty set. You could say the null set. You could use this symbol. This is the most popular because it's quick. Or you could put two braces with nothing in between. It's empty. So different ways of saying empty set. You have an option. We also use Venn diagrams to describe sets. It's a very, very good visual way, good aid, visual aid to use. The U stands for the universe. Every problem has its own universe, whatever you're talking about. And that universe has members. So right here we have two groups. Group A and Group B are in the universe. Then we have the complement of a set. And the symbol is that little bar, you see that. So this is the complement of A, the complement of A. To remember what you need to do when you have a complement, there's different phrases that you could remember. When you're looking for the complement of A, you could think of not A, exclude A, everything but A, the opposite of A, or remove A. So right here, there's an interesting result of the complement of a set. Notice A is whatever's in this circle. So whatever's not in this circle is the complement of A. But if you were to put them together, if you were to join them, form a union, you will produce the universe.